Unit 3. Universe and the Solar System. Lesson 2. The Solar System. The Solar System consists of Sun, 8 planets, comets, asteroids, and moons. The Solar System extends over 1,200 million kilometers in the space. The Sun is the center of the Solar System, and it represents more than 99% of the total Solar System. Newton's law of universal gravitation. The force of attraction between two bodies is directly proportional to the product of their masses and is inversely proportional to the square of the distance between them. So as we can see here, the force of attraction between two objects like Earth and any object on it is directly proportional to the product of their masses, mass of Earth and mass of object, and is inversely proportional to the square of the distance between their centers. Newton proved that the gravitational force makes planets revolve around the Sun in fixed orbits. The matter of each celestial body remains firm. Planets or moons attract gases toward itself, forming an atmosphere around it. Center gravitational force. It is the force that keeps the continuity of the planets rotating in their orbits around the Sun. And this force is in the opposite direction of the gravitational force. So, any object which rotates around the Sun is affected by two forces. Inward force, which is the gravitational force, outward force, which is center gravitational force. And the two forces are equal in magnitude and opposite in direction. Weightlessness. It occurs in the spacecraft as astronauts fall down inside it with the same speed. Theories about the evolution of the solar system. We will study 3 theories only. The first one is called Nebular theory. This theory is prepared by Laplace in 1796. The second theory is the crossing star theory, prepared by Chamberlain and Moulton in 1905. The third theory is the modern theory of the world, or Alfred Hale in 1944. The third theory is the modern theory about the world, which is presented by Alfred Hale in 1944. Nebular theory, Laplace 1796. This theory is based on the following observations. 2 observations. The first one, there is something that looks like clouds or nebula in the space. What's meant by nebula? It is a glowing gaseous sphere revolving around itself, from which the solar system was originated. The second observation is the space contains cloudy rings surrounding some planets, such as the rings of planet Saturn. Saturn is surrounded by a gaseous ring. According to these 2 observations, Laplace formed his theory. The assumptions of nebular theory, 3 phases. Phase number 1, the nebula, or glowing gaseous sphere. Over the time, the nebula lost its heat gradually, so its size contracted and its revolving speed around itself increased. Phase 2. The gaseous rings. Under the effect of centrifugal force, the nebula lost its spherical shape and became in a form of a flat disk. So this spherical rotating sphere changed under the effect of centrifugal force into a flat rotating disk. Parts got separated, as you can see from this image, from the flat rotating disk to form a gaseous rings that also rotate in the same direction in which the nebula rotates. Phase number 3. The formation of the solar system. The gaseous rings cooled down and frozen, forming the planets of the solar system. The flaming mass that remained in the center formed the sun. So the gaseous rings formed planets and the glowing sphere formed sun. The second theory is the crossing star theory. The solar system was originally the sun. At the beginning, there was only sun without planets. According to this theory, a huge star approached to the sun. This star attracted the sun to it, which led to a great expansion in the part of the sun facing it. This is the expanded part from the sun due to the huge gravity of the star. This expanded part was exploded, which led to a gaseous line was formed for a great length from the sun. This is the gaseous line which was formed. The sun escaped from the gravity of the star due to the reaction of this explosion. A gaseous line started to condense due to the attraction force, then it cooled, forming the planets. The third theory is modern theory about the world. Alfred Hale, 1944. Assumptions of Alfred Hale theory. The solar system was originally a star rather than the sun. So according to Alfred Hale theory, we have the sun and another star. This star was rotating near the sun. The star exploded due to huge nuclear reactions. The force of the explosion led to the bombing of the star's nucleus away from the gravity of the sun. A cloud of gases remained, and this is the most important part, this cloud of gases. The gaseous cloud subjected to cooling and contraction processes forming the matter of the planets. Then attraction force of the sun controlled the orbits of the planet around it. So this gaseous cloud cooled down and contracted, then it formed the planets. Day and year difference between planets. Earth's day, 24 hours. It is the time taken by Earth planet to complete one rotation around its axis. Earth's year, which is equal to 365.25 day. It is the time taken by Earth planet to complete one rotation around the sun. Factors led to the difference in the length of the day. The first factor is radius of the planet. The second factor is speed of rotation of the planet around its axis. Factors that led to the difference between the length of the day of different planets. The first one is the radius of the planet. As the radius of the planet increases, the length of the day on it increases. The second factor is speed of rotation. As the speed of rotation of the planet increases around its axis, the length of its day decreases. Factors led to the difference in the length of the year. The first factor is the distance between the planet and the sun. As the distance between the planet and the sun increases, as the length of its year increases. The second factor is speed of rotation of the planet around the sun. As the speed of rotation of the planet around the sun increases, the length of its year decreases. We have to memorize the length of day and year of each planet in terms of Earth's day and Earth's year. As you can see, 1 day of Mercury is equal to 59 days on Earth, and 1 year on Mercury is equivalent to 0.24 year from Earth's years, and so on. As you can see from the table, we can conclude that the longest day is on Venus. 1 day on Venus is equivalent to 243 days on Earth. The shortest day is on Jupiter, which is equivalent to 0.41 Earth's day. The longest year is on Neptune. 1 year on Neptune is equivalent to 165 years on Earth. The shortest year is on Mercury. 1 year on Mercury is equivalent to 0.24 years on Earth. Science, technology, and society. Spacesuit. Astronauts wear spacesuits during their space trips. Important instrument to study the outer space. Number 1. Solar telescope. Place. It is centered on the Earth, as you can see. This one is a solar telescope and this one is a solar telescope. It forms a picture of the sun. This telescope is used to collect the sunlight, then separate it into solar spectrum by the spectrometer. Astronomers got most of their information about the sun from the study of its spectra. Telescopes rotating in orbits around the Earth are better than that are being on the surface of the Earth because they can see celestial bodies more clearly. They catch rays that can't be able to penetrate the Earth's atmosphere. Examples for telescope: Hale telescope. It rotates around the Earth at a height of 500 kilometers. It collects photos for the universe since millions of years. These photos give astronomers an opportunity to study the evolution of the universe after the Big Bang. The third instrument is spacecraft. They revolve around other planets or land on them, sending discoveries to the Earth. This is the end of lesson 2. Thanks for watching.